This is a short video about solderless breadboards. They're fairly simple to use. They're not very expensive. They're fairly reliable. Basically, there's a lot of holes that are set on 1/10 of an inch centers. All of these holes line up so that ICs and other components will just plug directly into this board. These holes are interconnected like this. All of these in this column are connected together. All of these in this column, they're all connected together. However, these two columns are not connected to each other. So when you plug an IC in here, you'll be able to attach to all of the pins without interfering with other connections. All of these pins are connected together, and all of these pins are connected together, but they are not connected to each other. The design of these boards varies. There's different companies that have different sizes of boards, but they basically follow those same rules. So you may be able to find a board that's just half this size, and you may be able to find a board that is longer than this. But they all follow this pattern of where all of these pins are connected, and all of these pins are connected, but they're not connected to each other. By the way, these pins are not connected to these pins. Each column on each side is independent of each other. So when you plug a wire in here, it's connected to these 5 holes only. So if you need to bus a bunch of wires together, you run a wire from here over to here, then that connects these to these. There's only some slight variations other than the size of the boards. They're almost all on 1/10 inch centers because that is what most through hole components are designed for, and it's kind of a standard. When you get to surface mount technologies, you're not going to be able to use a breadboard with them directly. What you'll have to do is you'll have to mount those on a small, a little tiny, like 1-inch square board that then has pins that are on 1/10 inch center, so you can plug those directly into this solderless breadboard. There's a couple of features. Some of them have holes through them. This is for attaching to a plate of metal or something, so you can basically combine a dozen of these into one big circuit if you want to. Most of them have some way to connect to other boards that are the same model. Unfortunately, companies haven't standardized this, so different boards have different connectors, so you can't buy 3 different brands of boards and stick them all together. But for the most part, when you find one that works, you kind of stick to it. When you go to use these, you'll take something like an IC, and you simply place it in the center like this, and then you can just snap it right into the board. Now you'll be able to connect to each pin of this IC through these receiver ports, these receiver pins. And I want to make, just notice how I did this. Notice that there's this channel up the middle. That's for putting a little precision screwdriver under there, and then you can pry the end of that IC up, because that when that IC is down on this board like this, you can't really get a hold of it. So you can put a little screwdriver in there. If you mount your ICs to where you can't get access to that channel, like right here to right here, you're going to have a little more trouble getting that IC out of there. Now there's numerous components that fit in here, like potentiometers. They simply line up and you can push them right into the board. Little trimmer pots, they're also set like just about anything you have. Anything you find that's designed to go through holes on a board will fit in this solderless breadboard. Now the orientation is important. For instance, things like this, they have pins down each side, so you have to put them in here and you have to straddle that middle gutter. If you put them this way, well, all the pins on this side are now connected and all the pins on this side are now connected. Or at least part of them are. The top and the bottom pins are connected. In any case, almost all through-hole components will just plug directly in to one of these. These are fairly cheap and they're fairly reliable. This one I use quite a bit, and I bought it in 1988 and it still works fine. I wanted to show you I can take other boards like this and simply place them in here, give it a little push, and now I've got a much larger breadboard. There is no electrical connection between these, so if I want to bring power over to this board, I need to run a jumper from here up to here, then up to here. And then same thing with ground. I would run a jumper from here down to here, down to here, and that would connect the bottom rows on each of these boards. Newer breadboards, and these are quite old, but newer breadboards will have 2 rows of pins across the bottom, so you can hook 2 different power sources up, a ground and a hot, or ground and 5 volts. And then on the top you can do a ground and 15 volts or a ground and 12 volts, or anyway, there's 2 rows of these pins across here. And one thing to watch out for, some breadboards have a break in between these pins right here. So these do not run all the way across the board. They just run to the center and then they run from here over. So if you run into that, all you really got to do is put a little jumper across there, but it can create some problems when you first get that breadboard and things don't work because you don't realize that there's a break there. A lot of breadboards put a blue line or a red line underneath this. If that red line is solid, that means all of those are connected, and if there's a break in the red line right here, it means that they're not connected, so you need to put a jumper across there. These don't have that, but some of the boards do. The other thing is, when you go to buy these boards, people have a tendency to buy little boards like this, little half boards, and that's fine. But what I've found is these larger boards are not that much more expensive, and you get twice the space to build your circuit. The other thing is if you only have half of this board, you get more than twice the space, because by the time you put an IC on here, there's not room for anything else. Where on a full-size board like this, I can put 3, 4, 5 ICs across here. So you get considerably more than twice the circuit real estate, simply because on those smaller boards you might be able to plug 2 ICs together, but then you can't plug any other components. So by the time you figure for an IC and a bunch of components, or a few components, you've used that whole board up. On these, I can put 2, 3, 4 ICs and the components on them, even though they're only about twice the size. And then real quick, as I separate these, on the back of these, a lot of these are, you can see through them, and you can see the metal connectors. These are little spring, kind of spring clip connectors, and they're just kind of pushed into the board, so you can see how everything's connected on this board. This is convenient because for several reasons. One of the things that happens on these sometimes is if you get an IC that is not quite, the pins aren't quite straight, and you do get it in the board, sometimes the pins break off and they get stuck down in here, and then you can't stick another IC in there because there's something already there and it bends the pin on the new IC. Well, on this board, like I said, this is from the late 80s. I can actually take these things out and clean them out and get all the broken wires and all that stuff out of there, and then put them right back in there. I've done that quite a few times, but generally as you use these, you learn not to make those mistakes because it's kind of a pain to fix. But anyway, these boards are cheap. Back in the 80s, they were about $50. This ran about 50 bucks. Now you can find better boards than this with more tie points for under 10 bucks. And if you shop around, you probably get them for under $5. One last thing I wanted to add about these: don't get the idea that you're going to build giant circuits and use this for any kind of permanent circuit. This is really just for prototyping and doing some testing. The reason that you can't build permanent circuits on these is because these are friction connections. There's nothing that really holds that IC in there other than the friction between the clip and the pin on that IC. So over time, vibrations from vehicles driving by, from the frequency the circuit operates at, just tension on the springs, things like that, components will vibrate loose out of this over time. And I'm talking about months and years, but this is not a reliable connection for anything other than testing. The other problem with solderless breadboards is, as you learn more about electronics, what you're going to find out is that there is a component called a capacitor, and it is basically two plates that are next to each other. So one of the problems these breadboards, these solderless breadboards, is they have a relatively high amount of capacitance just in the design of the board. There's not any way around it. So you're somewhat limited on the frequencies that your circuits can use and things like that. So this is not a permanent circuit solution. What this is for designing and testing and learning. And then when you get your circuit all designed and tested and everything's done the way you want it, then you print a circuit board, what's called a printed circuit board. You make one or have one of those made, and then you solder everything in, and that fixes the issues with vibrations. And then in the design of that printed circuit board, you are also going to learn that you may have to position components close together and do things to get rid of what's called stray capacitance or parasitic capacitance on that board, so that your circuit operates at the frequencies you want it to operate at. The higher the frequency, the more difficult that board is to design. This will work for reasonably high frequencies, but the capacitance eventually will be so high that the circuits, you won't even be able to prototype really high frequency circuits on these boards. Anyway, this is a learning tool. If you design anything that you expect to operate in the high megahertz, it's not going to work on this board to begin with. I see a lot of people try to do that, and I have to go, you did a lot of work here, but unfortunately this is why it won't work. And there's not really a way around it. There's a reason we still use printed circuit boards.